Hello guys, welcome to my channel. In this lesson, we are going to learn how to reduce rational expressions. Let's take one example. We're going to look at the example x squared minus 4x divided by x squared minus 16. Okay, so this is an example of a rational expression, right? Okay, so from here, we can look at, let me show you an example of what we're doing right here. You know that we can reduce fractions, okay, because this can also be called a fractional expression, right? It's fractional expression. So because of that, we can look at that and compare that to maybe, for example, you're looking at reducing the fraction 8/10. To do that, you have to look for common factors. You've got factors of 8. The factors of 8 are 2 and 4. 2, 4, 8, right? So, but then we're looking at the product of those factors. So we can do that as maybe say 2 times 4 is 8. And we know that 2 times 5 is 10. So in order to reduce this expression right here, this fraction right here, I would just have to divide the common factors. So which means I get 4/5. Okay, so now this is what you're doing here. We're going to carry that understanding to what we have right here. So again, I am going to need to factor this expression in the numerator, which is going to be x times x minus 4. And then we'll divide that by, again, the denominator here is tricky. So there's something that you can do here to factor that expression. We know this is a famous expression in the sense that this is what you call the difference of two squares, because 16 is a perfect square. So that means you can write that as x squared minus 4 to the second power. And anytime you have an expression like that, a difference of two squares, you write that as x minus 4 times x plus 4. In general, if you have like x squared minus y squared, okay, then you can factor that into x minus y times x plus y. So this is what you have to keep in mind always. You're reducing rational expressions. So from here, I can now see some common factors that I can divide. So I'm going to cross out x minus 4 and x minus 4. And I am going to be left with x divided by x plus 4. This is good. But one common misconception that I would like to point out here is please do not make a mistake and do x over x plus 4 and then cross out x and x. You can't do that because in the sense that you have x and x is plus 4. So this x is no longer alone. So there's a 4 added to x. So it would not be equal to the numerator, which is just a single x. So you can't do that. The only time you can cross things out is when you have like x plus 4 divided by x plus 4. So you cannot cross things out if you have x minus 4 here. So for example, you can't cross that out and then end up with -1. You cannot do that. So you need to be very careful when you're dealing with expressions like that. Let's look at another example. Let's take example 2. For example 2, I have x to the 4th divided by x to the 3rd power minus and 2x to the 2nd power. So in order to reduce this rational expression right here, I know that x to the 4th factors into x to the 2nd power times x to the 2nd power. The reason why I'm doing this is because I'm looking at my denominator and I have x to the 3rd power and x to the 2nd power. So what I'm going to do here is just factor x to the 2nd power, okay, and then have x minus 2. So again, I know that this is just the reversed form of my distributive property. Again, when I distribute this way, I can get the original, right? So this is good enough for factoring. So what I'm going to do now is to look at the common factors for the numerator and the denominator that I can cross out. So you have x to the squared and x to the squared. So which means I'm going to be left with just x squared divided by x minus 2. Again, we said we would avoid crossing out variables like that, because it's x to the second power and it's just a single x, so we can't do that now because the denominator is a difference. Okay, the difference, so you can't just cross x and x squared out this time. So this is what we're working on. Okay, this will be your final reduction. So let's take another example. Let's take, for example, we have another one. We have this rational expression here, 2x squared plus 6x divided by 4x plus 12. Why don't you pause the video a little bit and try this out yourself and see if we're going to get the same results. All right, welcome back. Okay, so for this situation here, so what I'm going to do here is to look at factors of 2 and common factors of 2 and 6. Yeah, so I have the common factor of 2 and 6 is 2, and I also have the common factors of x squared and x, that's just x, and then you factor that into x plus 3, yes, x plus 3. Again, look at your distributive property and do that backwards to see, look backwards to see if that gives the original expression. So I'm going to divide that by looking at the common factors of 4x and 12. I have 4 in x plus 3. This is what I get. All right, so here I am going to look for the common factors that I can cross out. I have x plus 3 and x plus 3, and that leads me to 2x over 4. Well, it looks like I'm not done here because I know that the denominator can be factored into 2 times 2, right? So if I do that, I can now cross out a 2 and 2. I'm finally going to end up with x over 2. This is good enough. All right, let's take the final example. Final example here is x squared plus x minus 6 divided by x squared minus 4. Okay, to reduce this rational expression, I'm going to look at the numerator to see if that's not prime. If it's not prime, then I can factor that. Again, we can factor this into x minus 2 and x plus 3. We've seen this expression before in previous example. So I'm looking at x minus 2 and x plus 3. And I'm going to divide that by, this is a difference of 2 squares because I can write that as x squared minus 2 to the second power. So following the example above, that means I can write that as x minus 2 and x plus 2. So I'm just going to borrow that and bring that over. It's x minus 2 times x plus 2. And then looking at this expression here, I found my common factors that I'm going to reduce. So that means I get x plus 3 divided by x plus 2. So this is good enough. So I cannot just take my pen now or just cross out and cross out. If I do that, I would get in trouble. So I don't want to do that. So just take that away, take that away. So it means your final result will be x plus 3 and x plus 3 and x plus 2. I hope this is helpful, and I will see you in another video. Thank you very much.